An ellipse is the collection of points in the plane, the sum of whose distance from two fixed points is constant. So here I have drawn an ellipse. The two fixed points are called the foci. I have them labeled here as F1 and F2. And what this definition is saying is that at any point, the sum of the distances from F1 and F2 is the same anywhere along this ellipse. So this point, if I take the distance from the point to F1 and the point to F2, add them together, it will be the same as a point, well, I can't see that, but a point over here. If I take the distance from this point to F1 and this point to F2 and add them together, it will be the same as I had done over here on this point. And it will be the same for this point, any point along the ellipse. That is the definition of an ellipse. So now that I know what the definition of an ellipse is, how do I get an equation for an ellipse from this? Here's a mathematical expression of what this definition is. The distance from the focus to a point, well, from the first focus to the point, plus the distance from the second focus to the point is equal to a constant. So let me start setting up the information I have on the graph. Now this equation is going to be for an ellipse that has a major axis along the x-axis. It would be slightly different if this was rotated and the major axes were along the y-axis, but that will be an easy problem to solve once I already have the equation for an x-axis. And this is going to be at vertex 0, 0. I can do one for hk as well, but that's just simple. I just subtract h and k, so I don't need to worry about that for now. And I need some more information. The location of my foci. And here I have them labeled as F1 and F2, or C1 and C2. Now, I have them labeled as C1 and C2 because I have a triangle drawn here, and this will come into play later. But this side is C, so it will be C units from the origin, or the vertex in this case, to the focus. So if it is C units to the focus over here, that means it'll be minus C units to the focus over here. So F1 will be minus C, 0, F2, positive C, 0. And my point is xy. So with this information I can easily at least set up the left-hand side of my equation, so I'll go ahead and do that. And then this is equal to a constant. So now I need to figure out what to do about this constant. And an easy way for me to get a value for this constant, since it's going to be equal no matter where I take the distance from along this ellipse, I can just make things easy for myself by taking it at the point of the minor axis, which is the y-axis in this case. If I take it at exactly here, where this angle is 90 degrees, the distance from the point here to the first focus and the second focus is going to be equal, because this is going to split these into two equal triangles. And if I label this long side of the triangle A, which in this case is the distance, then it's going to be, the constant is going to be 2a, because it is the sum of the distance from the point to F1, which is a, and the distance from the point to F2, which is also a, because these are two equal triangles. And not only that, eventually what I will be able to do is use Pythagorean theorem to help give me an equation. Since this is b and c, I can do a squared plus b squared is equal to c squared at some point, and that's going to be how this is done. So for now, this is my equation so far. What I need to do is subtract one of these over to the other side. Well, I don't have to, it'll just be a lot easier if I do. Subtract this over to the other side and then square it. So I'll write it out first just so it's very plain what I've done. And now I'll square both sides. And I'm going to multiply this out. Don't need to waste a bunch of time. So this will be 4a squared minus 4a times this whole thing. And then I'm going to multiply this out as well. So this is minus, so it'll be positive. Oh, this is an x here. Yeah. Now I gotta cancel out like terms. So there's c squared on both sides, and I know there's a y squared on both sides. Okay. And what I'm going to do is add this over to the other side. This will give me 4xc, and I've got 4 on all of the terms now, so I can just get rid of that. And what I'm left with is xc is equal to a squared minus a this thing. So I'm going to square it again in order to get rid of this radical, so I'm going to subtract this over to the other side. Now I'll square it. So it'll be a squared times, what's all this, x squared and it is necessary for me to multiply all this out, unfortunately. It's an x. I don't know why I put a there. I was thinking about a too much. Okay, any like terms? Yes. Let's get rid of that. Squared c squared plus a to the fourth. A squared. And now I need to get all the like terms on one side. So x squared c squared. So the fourth. So factor out x squared here. C squared minus a squared. Yeah, this is how I do it. I can factor out a squared over here. Yeah. And this is going to be the part where I'm going to use Pythagorean theorem. Now, it looks a little bit funny because normally C is the long side, but in this case, I mean, you can label it however you want to, but this is just the way I did it. A is the long side, so A squared is equal to B squared plus C squared. So it looks kind of funny because normally A squared plus B squared is equal to C squared, but just the sides are labeled differently here. This is opposite of the 90-degree angle, so this is hypotenuse. So A squared minus C squared is equal to B squared. Yeah. So let me write that down here in a different color. A squared minus C squared is equal to B squared. But that's not what I have here. I can't just substitute this in here because C squared minus A squared, this is A squared minus C squared. But what I can do, and sometimes it's one of those things that you don't think of right away if you haven't done math for a long time. It's just to take out a minus sign, and that will solve it. It will reverse it. So if I pull out a minus 1 of here, and I pull out a minus 1 of here, I get minus x squared. The signs will reverse. And then I can multiply both sides by minus 1. I'm just doing it the long way just so it's not confusing to someone that got to this point and then couldn't figure out what to do. And I know it's really stupid. You probably feel really stupid after seeing it, but it's happened to me before, don't worry. Now I can make this substitution in here. A squared minus C squared is equal to B squared. I can subtract, well, I'll just divide up, well, yeah, I'll just subtract y squared over here first. So a squared, b squared, plus y squared, a squared is equal to a squared, b squared. And I divide both sides by a squared, b squared, x squared over a squared plus y squared over b squared is equal to 1. And that is an equation of an ellipse. And, well, I guess that's not really the whole thing. I mean, you gotta write that b squared is equal to a squared minus c squared. And this is for an ellipse that has major axes along the I was about to say the H file, but this isn't chess. This is math. This is the equation of an ellipse for an ellipse with a major axis along the x-axis. And I almost said X file there. Yeah, I was playing chess. Sorry. But yeah, this is for an ellipse with a major axes along the x-axis. If it were for the y-axis, if this were an ellipse with a major axis along the y-axis, then it should be pretty obvious what happens. Instead of the focus being C0, it would be 0, C. I thought I said Z for a second. Yeah, I need to just hurry up and finish this. I'm thinking about something else. And if I were just to switch this location of the C's, it should be pretty obvious what would happen. I would get x squared instead of x minus c, and I would have y minus c, y plus c. And essentially, basically what would happen is that these a's and b's would reverse. So this is for x major, and then for the y major axis it would be x squared over b squared plus y squared over a squared is equal to 1, and then this would still apply, b squared is equal to a squared minus c squared. And one more thing, I guess, it's if it were a center at HK, then I just simply subtract the center, so it's be x minus 8 h, that's an ugly h, squared a squared y minus k squared over b squared. And of course, if it were x major, and for the y obviously it would just reverse the a and the b.